Okay, nth roots. Here we go. Okay, a radical is another term for nth roots. Square root, as you see there, is the most common one you know. Sorry about hitting the slide too fast. There you go. All right. We all know this is a square root symbol, yes? Okay, that's not news. This is technically just a version of what is a radical. Okay, a radical is a general term. Square root is specific to square roots. Okay, and I know that sounded dumb, but it'll make sense once we get into this lesson. Okay, so radical is a term for nth roots. Basically, here's what you're talking about. What's 5 squared?
25.
25. Okay, what's the square root of 25? 5. Okay, makes sense. Square root, square, undo each other. All right. What's 2 cubed? 8. So there's also, just like how there's a square root that'll undo a squaring, there's a root that'll undo a cubing. Cube root, exactly. Okay. You got cube roots. We got fourth roots. We got fifth roots. And the reason why the slide in the lesson is titled nth roots is because theoretically, your root could be as big as you want it to be. You could take 100th root of a number if you really wanted to. Don't know why you would, but you could. So that's why it's called nth roots. Okay? You guys probably won't go bigger than 5, maybe 6. As far as the roots you're working with. Okay? Now, the notation for an nth root. We know the notation for a square root. We've seen that for forever. The notation for an nth root is you'll have the same radical sign you're used to, the same square root sign you're used to, but you're going to have a little number right there. Okay? You're going to have a little number right there, kind of in the crack of the radical sign. That number is called the index. That number is without a doubt the most important number the next 3 times we're together. Okay? You don't understand that number and the power that that number possesses, you don't understand anything. And we'll go into that. Yeah. Okay? If you don't understand the power that that little bitty number possesses and what it does to your problems going forward, you're in trouble. You must understand the index if you're going to get this. Okay? And I know that's just telling you what it is. It doesn't tell you anything about it right now. Okay, we'll get there. Little fun thing, not fun, but old stuff. Radicand is what's underneath the radical. Okay? So I'm going to be saying these. All right? Radicand, index. Make sure you know those 2 vocab words. Okay, so you really, you don't necessarily need this up here. It's kind of just showing you. The examples down here will make more sense, okay? I'd write down the nth root, though, what it is. It's the inverse of the nth power, okay? And remember, n just means whichever you're talking about, whether it be squares, cubes, fourth, fifth, sixth, doesn't matter, okay? It can be whatever one we want it to be / need it to be. Okay, so for example, like we said earlier, 5 squared is 25, therefore the square root of 25 is 5. Okay. But then once you move on from that, you move into the bigger powers, like 7 cubed gives you 343. To undo that, you need a cube root, which is right here, and that's your first look officially at what an index looks like. Okay, it's this little number right here. Okay, the cube root of 343 equals 7. Just undoes that cube power. 2 to the 9th is 512, so the 9th root of 512 is 2. And in a little bit we'll get into how to handle that and everything else. It's not a whole lot different from your regular old-time square roots. Okay, now, for reasons that you guys aren't fully privy to yet, and for reasons that I have, you need to know these, what ends up being, I believe, 18 powers. These 18 roots. And you need to know how to do them both ways. The reasons as to why you need to know them will become apparent as we work through some of these. But trust me when I tell you, you need to know them. You need to know them, and you need to know them well. Reason being is for a lot of things, but here's your most immediate one. Next week, one day, you will have a pop quiz. It is the only pop quiz I give. Your pop quiz will be over these. And that's it. And you will have 1 minute and a half to do it.
Those 6?
Hmm?
Those 6 things right there?
These 6 and these 12.
12.
Square root of 1 equals 1, all the way through the square root of 144 equals 12. That's the dots.
So it's square root.
Okay. First one. Now, these are going to start getting... I will tell you this, okay? Today, they start this, and this is out of the old book, all right? And they start this section of that chapter, which in my opinion should be in this new book. I don't know why they took it out. It's good stuff. It's stuff you guys need to know. Today, everything works perfect, okay? Everything is perfect. And what I mean by that is you should not have any square roots or any other kind of radicals in your answers, okay? Today, that's the case. It's not the case the whole chapter, but it is today. All right? So these should all, no answers you give should have radicals in them. All right? Now, we have the square root of 16y to the 4th. Okay? Don't tell me the answer, tell me what we do. We always do what? I'm looking for 2 words.
Factor tree.
Factor tree. Okay? You always factor tree. You go through 16's factors. 16's factors are 4 and 4, and you always look for what? Pairs. Keep that in mind. Okay? You always look for pairs. Here's your pair of 4s. They come out as 1, 4. Good. All right? Everybody good there? Old stuff, right? Now, the y to the 4th. You can also factor tree him. 2 and 2. Not 2y and 2y, but
2 and 2.
y squares. Because y squared times y squared is what? Y to the 4th. And you need what? Pairs. Look what you have here. Another pair.
Comes out as 1.
Comes out as 1 y squared. Ah. Okay. 4th root of y to the 4th. Okay. Now, you always start with still the same steps. You still factor tree everything, okay? And then whatever you want to factor tree is what you need to work on and stuff like that. But I'm going to factor tree this guy y squared, and I'm going to factor tree each one of those y's also just because I know what I need to get to, and I'm going to teach you guys that. All right? Y to the 4th is y times y times y times y. Everybody good with that? Makes sense?
Yes.
Okay. Now, the most powerful number in these problems is your what?
Index.
Your index. What's your index here?
4.
4. Here's why it's the most powerful number. It determines how many you need in your groups.
That makes sense.
Okay? It determines how many you need in your groups.
Because like in a square root, you're finding 2.
You need 2.
So there's a 4. And
You need 4.
then there's 4 y's, it's just y.
That's it?
The end. The end.
Do you have to show your workman?
Not really, no.
So I could just put
Because
one?
could you just
Yeah.
look at it and be like,
Yes.
or
Yes.
Finally.
Yes. Because, and here's why.
No idea.
All right.
Coach Fraser. Yeah, do Coach Fraser.
Factor tree. 3 and 81. 81 goes, I'm shortcutting you, 9 and 9. Your 9s go 3, 3, 3, 3. So there's all your 5 3s. See that? Okay. They all come out as
3.
a 3. Good. All right. Now, a to the 20th, b to the 25th. Think about this. You need groups of what?
5.
You need groups of 5. Okay, now think about this. Think back when you first learned how to do stuff. If you have 20 of something and you need groups of 5, how many are in a group?
4.
4. That's your power on your A.
That's a shortcut.
Okay?
And then B is
Okay, you have 25 things now. You still
5.
need them in group of 5s. How many are in a group?
5.
5. What do you do?
Take out a 5.
No, all in general.
25 divided by 5.
You divide the exponent
By the index.
by the index.
But you already know it's going to be 5.
That's how you know.
But what if there's,
I just
oh,
did
you
the
don't,
long line. It's like when you learn long
what if it's not divisible?
Yes, that's what I thought when I put this problem. I'm trying to be ignorant. Here's what you think of, okay? You have the square root of the quantity x squared minus 6. That quantity is to the 8th power. Bless you.
Thank you.
Okay? Now, here's where you kind of need to start thinking a little bit ahead and start taking your thought process to different things. What are you taking the square root of?
everything under the
Everything underneath the radical. How many of those everythings are there?
3.
No.
2,
No.
4.
No.
1,
No.
8.
8.
Oh, yeah.
There's 8. You're taking the square root of that binomial, and there's 8 of them. Okay? What's your index?
2.
2. Okay, if it's not there, if it's a square root, your index is 2. Okay? Assumed to be 2. You have 8 binomials. You need them in groups of 2. Or 2 groups. How many do you have in a group, Jason? 4. Okay? And that is all you care about.
You're kidding me.
Out.
No. Okay? You don't have to expand that out like we did last semester. Okay? Don't have to. Alright? But all you do is the index affects your big outside exponent, the exponent on that quantity. That's it. Okay? That's all it affects. It doesn't affect anything on the inside, just the outside. Okay? Nestor, good?
Yeah.
Or big.
Divide 8 by 2.
Yep.
And you don't, like, get rid of the 2?
Nothing on the inside.
It's the outside.
Don't touch the inside. Never touch the inside of binomials. Trinomials, whatever. Whatever is here in the inside, you don't touch it. You only touch the outside exponent. Okay? Let's skip these two just for time's sake. Yes.
Oh, jeez.
Okay. Factor tree 64. 8 and 8.
4, 2.
Faster.
2, 2, 2, 2, 2.
Bam, bam, bam. There you go. That's where I want your 3s. Okay, and this is why I want you to know in those numbers. Okay? Because as long as your leaves multiply back up top, it doesn't matter.
You can do as many as you want.
Okay, right. Okay? So you see 8, you know 8's 2 cubed, 2, 2, 2. You need 6 of those right there, they all are. All right? Way faster, way more efficient. But those 6 2's all come out as 1, 2. All right? That's the kind of the trick part. You have 6 2, now they all come out as 1. Okay? That's the kind of mind hurdle you need to get over, that they're all, your group's number is changing. Okay? Your index, the most powerful number. Pay attention to it. Okay, and then the square, you got to do the 6th root of x squared minus 3. So, x squared minus 3 does not get touched. Only the 18 does. What's your new exponent right here?
4. 3. Oh, my fault.
Wait,
You just flip them off.
Yeah, I used to put them off.
you don't,
Well, from your angle, I can see that. Yeah. Laney?
so you just divide it by 6, why don't you divide it by 2?
Hmm?
The other one you divided it by the,
Because that's what our index was.
um,
Here, your index is 6, so you divide it by 6. Okay?
Oh.
Number 9, 4th root of 16 is what? It's 2. Parentheses. X minus 3. This exponent becomes 3.
Man, I didn't